specialists at Virginia Tech. So we're gonna kind of dive into more of what exactly specially designed instruction looks like in mathematics. You guys did have the opportunity to talk about it a little bit yesterday, particularly in the disability awareness session. So just kind of think about what you guys discussed yesterday and apply that to what we're going to be talking about today. So if you take a look in the folder, so again, in that CTERM folder, there should be a folder for the specially designed instruction and mathematics session. And when you open that folder, there are 2 documents that I placed in there that are recently developed documents from the Virginia Department of Education. And I'm hoping that a lot of you have already kind of have taken a look at these. They've been out for almost a year, but we have a frequently asked questions document. That's the red one. So the PDF of that version is in the Google folder. And we also have an evidence-based specially designed instruction and mathematics resource guide. The frequently asked questions document is kind of, it gives a nice overview of what the characteristics of a mathematics disability is. And it also gives a lot of good information on what type of appropriate accommodations, modifications, and assistive technology would support a student with a disability in mathematics. So I definitely encourage you to take a look at the frequently asked questions document. I'm not going to be diving into that too much today during this session, but it really has a lot of great information, which I definitely encourage you to take a look at, and a lot of it you can use with your students. We're going to be looking more deeply into the evidence-based specially designed instruction in mathematics resource guide, which, as you can tell, is a lot lengthier than the frequently asked questions document, because it really details and highlights some specific evidence-based strategies that we can use with our students with disabilities. I did do a webinar on both of these documents back in the fall that kind of gives an overview of both documents and what you can find in them. So I did provide that link, and the PDF version of this PowerPoint should be in your folder as well. So the information that we're going to talk today about comes from those 2 documents that I just mentioned from the VDOE, but we're also utilizing some information in the book that that hopefully most of you have received, and if you haven't received it, you'll be receiving it soon. But that specially designed instruction for co-teaching, that there's a picture of it on the screen, by Marilyn Friend. All of you should receive that book as part of being a participant in this academy. And if you've already gotten it, you can tell it's really thick. So it has a lot of great information in it. So we're going to pick out some specific information, particularly about math, from this book. But again, this is a great resource. So I think you guys are going to find it very useful. And then we also took some information about from an article from Teaching Exceptional Children, and Margaret Weiss is actually a professor at GMU, and she's done a lot of work with inclusion and has done a lot of research in that area as well. Okay, so we talked a little bit about this yesterday, and it can be a little confusing. But really, when you think about specially designed instruction, and I think Crystal mentioned this yesterday when she was talking about it, it's really what the heart of special education is. Specially designed instruction means adapting as appropriate to the needs of an eligible child, the content, methodology, or delivery of instruction. And it is to address the unique needs of the child that result from that child's disability. And that specially designed instruction is really helping to make sure that we're ensuring access to that child to the general curriculum, so that the child can meet what the standards are that apply to all the kids in that jurisdiction. So in your book, the Specially Designed Instruction for Co-Teaching, it really, really does a great job of explaining exactly what specially designed instruction is in chapters 1 and 2. We could spend a whole day just really looking at the information that's in chapter 1 and 2 that really gives a nice job of defining what specially designed instruction is. So I really encourage you to read those chapters and to really just help cement in your mind what specially designed instruction means. So again, it's really that heart of special education. And I think Crystal mentioned this yesterday as well, is a student wouldn't be found eligible for special education services if that student didn't require an instruction that's specially designed to meet that child's needs. So it's individualized to meet that child's needs. If that child didn't need specially designed instruction, he or she wouldn't have been found eligible for special education services. So it's really that instruction that is exactly what it says, especially designed to meet what that child's needs are. This graphic was actually developed by one of our T-TEC specialists, Laura Beller. She's actually at William and Mary. And I love it. I use this almost every time I talk about specially designed instruction because I really think it gives you a really good visual and helps you understand exactly what specially designed instruction is. So if you look at this graphic, and you can see on the left-hand side, it has the student's present level performance. So that's of course what is described in the present level performance section of the IEP, what that student can presently do. And then that student, you have a goal for that student to be able to access and achieve grade level standards. So in order to go from this present level performance and to meet the grade level standards, a lot of different things need to happen. So you're really asking yourself, and that question in the middle, what does the student need that special education can provide? So that student needs specially designed instruction or special education in order to access the grade level standards and achieve the grade level standards. So, and as you can see at the top, the SDIs is one of the puzzle pieces. Okay, so that puzzle piece, that needs to be in the bridge in order for the student to go from, for the student to access those grade level standards. So thinking about what specially designed instruction is, and then you can look at all the different descriptors around it. It's instruction provided to address unique academic, behavioral, and functional needs. So yes, specially designed instruction can be in academics, which of course math is an academic. That's what we're going to be talking about today. But it can also be in behavioral and can be functional. It's specifically outlined in the IEP. So when you're coming up with the goals for the student in the IEP, based on that student's present level of performance, you're thinking about, when you're coming up with a math goal, you're thinking, well, and you're doing the standards-based goal, you're asking yourself, what are areas where the student needs specially designed instruction in order to meet that grade level standard? So it should be outlined in the IEP. It supports access to and progress in the general ed curriculum. And a really big one, if you see in blue there, it's right near the missing puzzle piece, is based on research or best practice. So when you're providing specially designed instruction, those strategies really need to be evidence-based and based on research and best practice. And it's intended to close that gap. It's intended to accelerate that student's learning so that they can get to that grade level. And then also notice in the red, it says provided by the educator. And they did a good job of talking about this yesterday as well. Specially designed instruction is what the teacher teaches. It's what is being provided by the educator to the student. It's what the teacher teaches. It's not an accommodation. Remember, accommodations are supports given to the student to help access the curriculum. So a really good example is you could give the accommodation of providing a multiplication chart for the student. That could be an accommodation. But it could turn into specially designed instruction when you explicitly teach the student how to use that multiplication chart. A lot of students, you give them a multiplication chart and they know what to do with it. They know how to use it. But then you will have a student with a disability in mathematics or has an IEP goal in math and really just needs that explicit instruction and that direct instruction on how to use that multiplication chart. So that's where it turns into specially designed instruction. So again, we're talking about math. Kim's going to do a session on reading tomorrow. So you'll learn some more strategies about reading tomorrow. But what are some examples of when you might provide specially designed instruction in a co-taught math classroom? So one opportunity is when you need to teach prerequisite skills required to learn new content. So your student might be missing some of those prerequisite skills that will help provide access to that grade level content. So that would be a perfect time to provide some specially designed instruction to that student. Another perfect time, which really is really required, is to teach skills that are part of the student's IEP goals. If the student has IEP goals in math, that student should be receiving some specially designed instruction in those goal areas. And that specially designed instruction is going to be very tailored and specific to that child's needs. And then it's also very, very, very needed when when the student requires a different delivery of instruction to master the content. Again, a student's not going to be found eligible for special education services if they're being successful in the regular ed instruction with the delivery in a regular ed classroom. So oftentimes our delivery to our students with disabilities needs to look different than what you're seeing in the regular classroom. So one of the challenges, and remember we talked in the very beginning of our of the academy yesterday, is that being in a co-taught or teaching in a co-taught classroom, being co-teachers is a service delivery model, and that really helps support the whole idea of inclusion. But it also adds some challenges because we really need to think about how are we going to make sure that our students are receiving their special education services? How are we making sure that our students are receiving that specially designed instruction that they need in order to access the curriculum? So really logistically, it can be challenging. So just thinking about the different co-teaching models that you guys talked about yesterday, there's a lot of opportunities when you can integrate specially designed instruction. And one of the really good time to do is when you're working in a small group. So like the whole the station co-teaching model. So and you can do that during warm-up activities. You could do it during extension activities. You could do the small groups during a time when other students are doing independent practice. I think warm-up time is a perfect time to integrate some specially designed instruction, because think about it. Most math classes start with like a 10 or 15-minute warm-up in the beginning of class. And if you're doing the warm-up with the entire group of kids, think about some of your students who struggle in math or who have math disabilities in mathematics. I'm willing to bet that those students are really not engaged in the whole group warm-up. Those are often the kids who might get up and sharpen their pencil or pretend they're looking for something in their book bag, or the whole avoidance behavior because they're not really sure what they're supposed to do. So I feel like warm-up time is a perfect time to make sure some of that specially designed instruction is happening. That 15 minutes is much better working in a small group and really learning something as opposed to just sitting and not being engaged in a whole group activity. In small groups, station model really supports the whole small group idea, but also the alternative teaching model, which we talked about yesterday. So, if you need to pull out or work with, not pull out, but work with a group on a prerequisite skill or reinforce a certain concept, you can do that during the alternative teaching model. And then, of course, other co-teaching models support it. Like I was talking about station teaching, parallel teaching is a really supportive model. Both teachers could be teaching the same content, but one group could be having a different delivery of that content, could be more of a specially designed instructional delivery of that content. So I put in parentheses, that these could all be applied in the virtual setting. There's a possibility that some of us might still be virtual this coming school year, but you can still integrate specially designed instruction even when you are in a virtual setting. So in chapter 4 of the specially designed instruction for co-teaching, that really dives into how you can integrate it into your co-taught classroom. If you have your book, if you've already received it in the mail, hopefully you have it nearby you, and you can take a look at some lesson planning templates. I think these are really awesome, but I think definitely encourage you to use when you're planning with your co-teacher. But on pages 93 through 96 in the specially designed instruction for co-teaching book are several examples of lesson plan templates that you can use with your co-teaching partner when you're designing your instruction. And like I said, it takes planning, and you have to be creative sometimes to really figure out logistically how to integrate the specially designed instruction. The picture that I have on the screen, that's just a sample taken from that article that I was telling you about that is in Teaching Exceptional Children. And that was just a nice example of like what the lesson plan looks like and where that specially designed instruction is integrated throughout the lesson plan. So you can see that, it has what the full class is doing and the content, and then what kind of specially designed instruction is happening with particular students. So when you take a look at those lesson plan templates in your book, you'll notice that is particularly the one on page 93, where your list, and this really also, I think, helps you be accountable to really make sure you are providing what your students need, because you're looking at what their IEP goals, so you're looking at what their needs are, what their characteristics are, and what kind of instruction would be suitable for those. Okay, I'm going to stop there, and I'm not I haven't really been taking notice of the chat, but Sue, do you notice anything that I need to address before we move on?
The main thing is people just want to know if they're going to get copies of the presentation, and I think we can share it with them when we're done, correct?
No, it's already in. It's in the.
Oh, okay.
Yeah, actually, so.
I put a copy of the guidance document and the frequently asked questions in the chat for everybody. They also would like to have a copy of your graphic, because that is an awesome graphic.
Yeah, it's in the, okay, so if you, I'm going to type it in the chat again. So if you go to that bit.ly site, and then you go in that folder, and you go into the folder that says specially designed instruction in co-taught mathematics classrooms. When you go into that folder, you should see the frequently asked questions document. You should see the resource guide. You should see a PDF version of our PowerPoint, which all the links will be active in that. That includes the graphic that I was sharing. And it includes other resources that we're going to be sharing today. So that should have everything.
All right, and Ruth, the bit.ly link, Kristin put it right above where you just asked for the bit.ly link, and you may have to copy and paste it, but you should be able to put that in your browser and it should go right to it. And then just people echoing that idea that SDI really is tailored to each student's specific needs. Just because a student has autism, it doesn't mean we can blanket put the same SDI for the next student who has autism. I like that you said that, Ruth, because you're exactly right.
Right, it's definitely tailored to individual needs. And a lot of times I hear, well, if the specially designed instruction works for our students with our students with IEPs or students with disabilities, why can't we just do it for everybody? If it works for them, it'll work for everybody. But that's not what everybody needs. There's that is tailored for that student's needs. Many of our students do not need, for example, explicit instruction. A lot of students who are in the regular classroom who don't have IEPs don't need to have that explicit instruction that a lot of our kids with disabilities need. So it really needs
and
to
to
be
tag on to
tailored.
that, Kristin, yeah, and to tag on to that though, the way I like to think of it is, so you might design that explicit instruction for this student who has a learning disability and you know they need it, but that doesn't mean this other student in the room who doesn't have the learning disability can also participate in that explicit instruction. And that's when it becomes differentiation. But when you designed it for that specific student, it was SDI. Does that kind of make sense? So they overlap, they do overlap, but
Right,
that's the distinction, is when I make it for one student, it's their SDI. Other people can access it as differentiation.
right.
But like
That's a
you
good way to
said,
look
not
at it.
everybody's going to need it. And some students are going to balk if you try to do that with them. So
Right, exactly. And that's, and Crystal made this distinction yesterday too, that we're required to provide that specially designed instruction by the law to our students with disabilities. So, we need to make sure that they're getting what they need. Okay, so we're going to move on. And if you take a look at the resource guide, the VDOE evidence-based strategies resource guide, it really dives into 5 very, very evidence-based strategies in terms of specially designed instruction. We're going to hit more. So the 5 strategies that it really talks about is explicit instruction, formal math language, concrete representational abstract connections, fact and computational fluency, and word problem solving. We're going to really dive into the red topics. And we're going to briefly touch on the topics that are in black. But again, they're all explained very much detail in the guides. So you can always find out more by looking through the guides. But we really wanted to kind of focus on the explicit instruction and strategies for word problem solving, because word problem solving, when we get to, we all know that's like the area that our kids need help in.
I'll also tell you in that guide, there are links to modules that are professional development on each of these sections. Sarah Powell has developed just some great, there are videos and handouts. So, if you as a PLC or you and your co-teacher want to dive deeper, there's lots of ways to dive deeper into the ones we don't go deep into today.
Okay, we're going to start with explicit instruction. So if you're looking at your resources in the resource guide, this is talked about on pages 6 through 11. And it's also talked about in Marilyn Friend's book on pages 237 to 239. We talked a little bit about explicit instruction yesterday. Dr. Morano talked about it a little bit this morning. So hopefully after I talk about it, you'll really have a better idea of what it actually really is and how it can be effective for our students. So explicit instruction is often described as the cornerstone of effective mathematics instruction for students with learning disabilities. And although you find a lot of different models of explicit instruction, depending on what resource you look at, this model that we're actually going to share with you was developed by the National Center on Intensive Intervention. And that is a really great resource site. And I think actually Dr. Morano had it linked in her slides as well. But when you're looking at explicit instruction, it's really made up of 3 components. You have your modeling component, which is facilitated by your teacher or by the teacher. You have your practice component, which involves the student and the students and the teacher. And then what I think is the most important part of explicit instruction is these supporting practices. And the supporting practices are really an ongoing dialogue between the teacher and the students. And you'll notice that the supporting practices are underneath both the modeling and practice, because you should employ these supporting practices throughout all of the modeling and throughout all of the practice. And again, this is very evidence-based for students with disabilities, but it doesn't necessarily need to be done with all of your students. But if you have a student with a disability who's really struggling in a particular concept, explicit instruction would definitely be an evidence-based strategy to try with that student. Okay, so we're first going to talk about the modeling. So your modeling prepares your students to complete the math skills successfully. So it includes two components. You have your clear explanation and your planned examples. So your clear explanation really talks about what's the importance of learning this? What's the goal? Why are we learning this? And you're really explicitly modeling the steps to solve that mathematical problem. And while you're doing that, you're making sure that you're including that important vocabulary and that you're using that concise math language. And you may choose to model one example, or you might choose to model several examples, depending on what the familiarity of the student is with the concept. It's really important to have planned examples. So this is something you don't want to do just on the fly. You really want to think carefully and plan what you're going to teach. So you want to make sure that your plan examples help the students understand the math concept, and that you also want to make sure that you're asking important questions. And you want to make sure you consider examples that are open-ended, but you could also include worked examples. And it's also just as important to include non-examples. So when a teacher models a lesson, it's really important that the student participates. So part of one of the key parts of explicit instruction is making sure that the students are engaged and that they're frequently responding and that they're participating. So the combination of asking questions and eliciting frequent responses is often misunderstood with modeling. Some teachers think that modeling is only just having a teacher demonstration and teacher talk. So a lot of times I hear people say, oh, explicit instruction is I do, we do, you do. But it's so much more than that. I really don't want you guys to walk away thinking that that's all it is. Because in the I do part, you are still totally engaging your student. And you're asking your students to continuously respond to what you're doing. So while the modeling prepares the students to complete the math tests, the practice provides those multiple opportunities for students to practice. So it consists of two pieces, the guided practice and the independent practice. So your guided practice, of course, is when the teacher and student practice together. So the teacher solves the problem while the students solve the same problem. It can take place at a table. It can take place with the teacher and students working the problem together, or the teacher could be solving the problem on a whiteboard and the students could be solving it on individual whiteboards. But it really helps students with learning difficulties and provides a gradual release of responsibility from the modeling to the independent practice. And then notice that it says student practices with teacher support. So independent practice doesn't mean we're just going to throw them off on their own and just give them a bunch of problems to do for homework by themselves independently. You still want to make sure you're providing some support. So it consists of students working independently as the teacher continues to provide feedback. Whoops, I'm sorry, I accidentally moved my next one. So again, you don't want to, you want to make sure that you're still providing feedback as your students are working independently and making sure you answer questions and giving that feedback. This part here, I think, is the most important part. And if you take anything away at all from today's session, is really think to yourself, when I do explicit instruction, am I employing these supporting practices? And remember, these supporting practices should be happening during the whole modeling process and during the whole practice process. So you want to make sure, are you asking the right questions? So you want to make sure you're asking both low level and high level. So remember when Dr. Marano was talking about it's important to make sure you're pairing the conceptual and talking about how and why things work, and to help kids with that conceptual understanding. So you want to make sure you're doing that even when you are providing explicit instruction. So those low-level questions require the simpler answers, and that's really helpful for making sure the kids understand the procedural part of it. But your higher level questions are really encouraging that deeper thinking and reasoning, and really allows you to assess your students' conceptual understanding of the concept, because we want kids to know why we're doing what we're doing. We don't want to just tell them to do it away and not help them to understand why and help them to understand the conceptual part of it.
Kristin, I also, Lisa Deeker, who is, one of the big co-teaching gurus, she always says, whoever's mouth is going, that's whose brain is growing. So like you're saying, those questions and student responses are crucial for students actually gaining knowledge. So yeah. I like that you stress that there.
Yeah, I like that. Another big part of it is that, and that kind of goes along with what you were just saying, Sue, eliciting frequent response. So you need, making sure that students are responding frequently really helps to make sure that they're maintaining their attention, and it helps you determine what they're getting and what they're not getting, and what you need to teach and what you need to reteach. You really should be striving for that constant engagement with your students. And responses can be all different kinds. They can be class-wide, they can be individual, they can be partner, they can be writing on a whiteboard, they can be thumbs up, as long as you're asking them for some type of response continuously. And then another supporting practice is providing that immediate specific feedback. So you want to make sure your feedback is both affirmative and corrective. So affirmative feedback proves most effective when students receive specific comments about concepts or procedures. Like you might say something, I noticed that you used the counting up strategy to add those two numbers. And then corrective feedback is provided by teachers when students make a mistake or misunderstand a concept. And it really involves encouraging the students to explain their thinking. So you might say something like, can you explain the steps you followed for this problem? This last one is probably most surprising to people, but you really should maintain a brisk pace. And mainly because you want to keep that engagement. You want to keep that student constantly being engaged. So really you want, which really, again, emphasizes that you really need to be planning your lesson ahead of time. Okay, so I'm hoping that you learned something new today about explicit instruction. So I would like you guys to chat or type in the chat box. What is something new that you learned about explicit instruction? So explicit instruction is an evidence-based strategy for students with disabilities. It could be considered specially designed instruction for, to help them understand different math concepts. So what's something you learned about it that maybe you didn't realize before? So yes, asking low and high questions, the quote about who's talking the most, their brains growing, keeping the kids talking and discussing, using whiteboards helps them. Yeah, I think that's kids love using whiteboards. I found that too. It's considered specially designed instruction. The supporting practices are so important. Maintaining the brisk pace. Yeah, a lot of people are surprised by that. Awesome. So you guys, it looks like you guys have learned some different things that maybe you didn't know before. And Sarah, I'm so glad you put that. It's not just I do, we do, you do. I really, if you go away with anything, it's so much more than that. Those supporting practices are really what makes it explicit instruction. A lot of us were taught in math classes of I do, we do, you do. That was not explicit instruction where we were constantly engaged. All right, awesome. So I'm going to stop talking because you guys are probably tired of hearing my voice, and we're gonna have Sue take over for a little bit.
Okay, and I have to tell everyone that when Kristin and I were planning, I asked her to take that explicit instruction piece because I just feel like she does such a great job of really going into how it is more than that. And like she told you in the beginning, I'm going to fly probably through these next 3 sections, so forgive me. But like we said, we really want to stress the explicit instruction and then at the tail end, the problem solving. So we have a activity at the end we want to get to. But like we said, it's in that guidance document and you can just go in there. You can contact your TTACs if you need more support or more resources. So if I'm going too fast, I am apologizing in advance. So when we speak about formal math language, this is when you go and look at math research, this is what comes up a lot that we're missing for all students, but especially for our students with disabilities. And we need to be using that formal math language, not calling it a diamond, making sure we say rhombus because we don't actually have a shape called a diamond. Things like not calling it a corner, it's the vertex. When we're talking about a fraction, we're not saying the top number, bottom number. We really want to use the math language of numerator and denominator, even with our little guys, our younger students. And we can pair it with other things or with gestures or with simpler language, but we have to be using that formal math language. And we have to make sure we're using the terms precisely. If we're talking about the numerator, we want to make sure we say the digit that's the numerator. Because if we say the top number, then kids get confused that a fraction is a number. They think a fraction is made of 2 numbers, when really the fraction itself is a number. So we have to be really careful about it. And then we have to make sure we're doing this concisely too. So we want to make sure we get that definition in a kid-friendly way and that we're delivering it in a way that they can walk away understanding it. Oops, sorry, I lost the slideshow, Kristin.
Yeah, I think you said some of these examples as you were talking about it.
Yes. So, and again, we have to be teaching this explicitly. So that explicit instruction that Kristin just talked about is going to get pulled into when we're doing our math language, and we're going to actually teach vocabulary, not just use it with our students, but then have them use it and interact with it. And yeah, it's not going to happen. Go ahead.
Oh, I was just going to say, I think that's a good distinction. I can't talk. Just trying to help people understand the whole specially designed instruction piece. So it's important that we use formal math language with all of our students. Like that's evidence-based, just in general. We need to use formal math language with all of our kids and try to get away from using the little trick words and so forth. But when it becomes specially designed instruction, is when you're being more intentional about making sure you're teaching the students the vocabulary. So your student with disability might need a more explicit instruction on what that vocabulary word means. In the COTOP, the specially designed instruction book, has some ideas on some strategies that you can use to teach vocabulary. So if you're using the Frayer model or using another specific vocabulary strategy and you're using that and you're explicitly teaching your students to use that strategy to learn vocabulary, that's where it would become specially designed instruction.
Exactly. And since it's specially designed instruction, specially designed instruction, it's not happening by accident. We're going to be very planned and purposeful about it. And so thinking about as a co-teacher, if we know our specially designed instruction for one of our students is pre-teaching, then maybe we're going to do alternative teaching the next day. And instead of doing the warm-up activity, either the special ed teacher or the general ed teacher, whichever one, is going to pull that small group of students who needs that pre-teaching, and they're going to do that explicit instruction with the vocabulary before we start the lesson that day. That way they start the lesson on even footing with the rest of the class instead of starting 5 steps behind. So let's really think about, why is precise language so important? Why does this pose a problem for our students, especially those who have math difficulties or a learning disability in math? Well, we know that our kiddos may be diagnosed with a math learning disability, but a lot of times they might have a partnering disability. That's what we call morbidity. I can't talk today either, Kristin. And research shows between 30 to 70% of your kids are going to have a second disability in addition to that math disability. And about half the time, it's reading is their other disability. So if they have difficulty in reading, that's going to impact their math and the language that goes with math. Does that make sense to everybody? So that's why we really want to stress the importance of this. So like it says here, instead of what number is in the tens place, because again, that double digit is the number. When we want that thing that's in the tens place, it's a digit. It's not the number. It is the digit in that number. Do you see the distinction between that? It's very subtle, but it's really important. And the other thing I would add to this, a great way, I went through a math specialist program and we had to record ourselves a lot. And I would be shocked and amazed with myself what I was saying at the end of a lesson after I watched it. And luckily we didn't have to share all of them with other people. So, I just got to be privately embarrassed as I watched my video. But I would highly recommend that. Record yourself and then, make a little checklist for yourself of the times where I did use precise language, I didn't, kind of put tally marks. And then make that your thing. It might not be perfect right away, but just to slowly improve it. Maybe as co-teachers, you're going to use the one teach, one observe model, and your co-teacher is going to help get that data for you. And then you two can talk about it after and then switch it the next day. So really think about how we can improve on getting our language more precise and more concise. A great resource, I cannot say enough for what Kristin and the math team have created at VDOE. And one of those things are these word wall cards. Does anyone put in the chat if you've seen or are using these word wall cards?
If you haven't used these before or you want to know where to find them, I just put the link in the chat.
As a classroom teacher, these were up in my room. We had fly swatters out and would actually do the fly swatter game where, we made a game out of it. My kids had personalized ones if they needed it, if they needed extra help, on rings that they could carry and then flip out when they needed them. The graphics that go with the words really help support our students with disabilities because they're not relying simply on the language. They've got that visual to help support the meaning. So let's see. Someone's planning on making one. Someone said they love them. They're great review cards. Exactly. So look in the chat and look at what your colleagues are doing. And again, as co-teachers, get them out, look at them and say, what can we do with these word wall cards? They're an amazing resource in addition to the SDI guide that we've been waiting for a long time. And until Kristin and the new crew came on, we didn't have it. So it's perfect.
Yeah. If you have any great ideas on how you use them, just add that to the chat box because we like to share ideas with each other. Yeah, lots of people use them for anchor charts. Teachers will make little index card size versions and put them on key rings and maybe have just the words.
And if you need help doing that,
or...
if you're not sure how to do that, what you do is when you go to print them, when you go to layout, you can tell it to do 4 sheets per page, and then you'll have 4 cards instead of a big 8x11. Just a little tip for you. And anchor charts, I hadn't thought about it as anchor charts, but I think that's a great idea, especially in stations. Great pulling in that co-teaching model. Yeah, while we're at stations, if it's an independent station, they have that support there to help them get through the station. That's perfect. Awesome. So now we're going to go into CRA, Concrete Representational Abstract. And this to me is the fun of math. This is where math is like play, not to say that we want students playing, but we do want it to kind of have that engaging element to it, and to have them tackle math concepts using those concrete manipulatives. It just kind of helps them make meaning out of the math instead of relying solely on this number that maybe I can't attach any meaning to, or a picture that I can't move around and I really can't figure out how these concepts fit together until I actually have my hands on things. And like the page before said, it's in that guide. So make sure you go in, and again, there's videos and lots of supporting materials in the guide. So you can see here that we've laid out the idea of CRA, concrete being the manipulatives, pictorial or representative being those pictures that you draw, and abstract are the bare numbers, what people usually think of as math. even though we all know math is the thinking, it's not just the numbers. But it's set up like a Venn diagram because they interact and you want to show them in overlapping ways. When I first learned about CRA, I was kind of told you only do concrete in the beginning and they have to show 10 times of mastering it before you move to the representational. And research is kind of showing that's not so true. You do want to start with concrete and you want to have lots of exposure with concrete materials, but you can introduce the pictorial and the abstract while you're working that way. Your primary mode might be concrete, but we're also going to be looking at some pictures and some abstract numbers while we do that, the math number sentence. And vice versa. Once we get to abstract, that doesn't mean we can't ever go back to concrete. If they're struggling, you can say, hey, let's get our manipulatives back out. Let's work through this problem and really look at it. So let's see. So some examples, as you can see here, when we're talking about concrete, there are a ton out there. And all the way through high school, I know a lot of people think once they're older, they don't need them. But my daughter, who was gifted, she's going to be working on her PhD in chemistry starting next year. I remember when she was in algebra and she was struggling with, I can't remember, it was factoring. And I had her get out the blocks and she was like, I don't need those. I don't need those. And yet within 5 minutes of working with those blocks, boom, she was flying again. So all students really can benefit from them. And we do have algebra tiles and algebra blocks that are used at the high school level. In addition to, you can see the first picture, there's a geoboard and we have angligs. So for geometry, we've got concrete materials. And then as we move to the representational, that's when we're going to start like representing what those materials were with our drawings or our diagrams. And virtual manipulatives kind of bridge those two worlds. And you can find a virtual manipulative for every manipulative out there. And I like to say it really is a nice bridge between working with that hands-on and going to the pictures. So we have lots of resources at the end for different ones you can use. And then our last step is we're going to start using our abstract concepts where instead of having 2 blocks and 3 blocks and I put them together to get 5, we're going to say I have the 2 plus 3 equals 5. We're going to actually go to those number sentences or the algebraic expression once we get to older kiddos. I think that's about it for CRA. So we put up some great virtual manipulatives, some great resources where you can find them. Can you throw in the chat anything that you use, if you've used any of these, if you have an additional one that you like to use?
Yeah, and I'll just make the point again that CRA is an evidence-based approach that works with all kids, but our students with disabilities might need more of CRA in order to access the material, or they might need more of the concrete before they can get to the representational. And just like Sue was talking about, looking at it like a Venn diagram, it really is based on individual needs. Some of our students can get to the abstract a little bit faster, but you still need to support that with the concrete and representational so they actually understand why they're doing the abstract. Some of our kids can memorize the procedures in the abstract form, but don't really understand the conceptual. So the concrete and representational really support that conceptual understanding. So again, when you're thinking about your student with disability or student with math difficulties, they might just need more of that CRA instruction and more intentional, more explicit, more practice with it. And that's where it turns into that specially designed instruction.
And again, thinking about as co-teachers, that might be then we have a station, and when some students are going there, we're going to use manipulatives again, but another group of students is ready to move on to representational and abstract. Just thinking about that. Someone mentioned that they sometimes feel like students with disabilities may rely on the manipulatives, and that's why it's important that we have them keep bridging. And we made a progress monitoring sheet. And we'll put it in the resources. I don't know if it got printed or not, but we'll drop it.
It's in the folder. It's in the folder.
I mean, that's a great way. And I would share it with the student. Tell them this is your progress. you're doing great things with these manipulatives, but at the end of the day, we want to be able to do it with the numbers too. And they can track their own progress with you and see how they're moving towards that goal of being able to do the abstract, if that makes sense. Someone else says they use ABCA, Raz Kids has some. Oh, someone else put Didax in there. That's a great one too. And Toy Theater. So check those out. I can't stress enough the importance. Even as adults, if you think about it, have you ever had a problem come to you and you had to get that pen and paper out and draw a picture of what you needed to do to figure it out? I know I have to do that a lot as an adult. And show that to the kids. Tell them that this is something you do as an adult, that it's not just because, oh, you're a kid and you don't understand, you have to do this. That's actually mathematical thinking, that's a big piece of it. All right, so fluency is another cornerstone for our kids with disabilities because it'll free up that working memory. And I know everyone in here, you know that one of the biggest problems for most of our students with disabilities is that working memory piece. So the more that they are capable to fluently work with facts, even just recognizing digits and knowing what the digits mean, like for our little guys or kids who are really struggling, sometimes we got to go back to just mastering, connecting what the digit means compared to a quantity. Once they master that, that frees up that space that they were using to focus so much on what that was, that they can move to higher level thinking. So like it says here, it's not about necessarily memorizing either. It's having strategies to be able to work with the numbers efficiently and accurately. We're not necessarily saying you've got to be, the speedy rabbit who's done first. We need you to get to that correct answer and without using a lot of your brain space or having to struggle to get there. We want you to be able to do it fluently. That's where that word comes from. So this needs to align with where they are, where the student is developmentally. Like I said, if you've got a student who's struggling to understand that digit 5, that number 5 means 5 items, we've got to get some 5 frames out and really build that fluency and understanding for what that number means before we can move to what is 2 + 3 = 5. And if you haven't used 10 frames, definitely get some 10 frames out because that's a great way. You could start with 5 frames actually, then have 10 frames, and then you do double 10 frames to do your double digit numbers. It's a really good way to concretely show what the numbers mean. So we have to assess our kids, know where they are, and then build from that. And this fact fluency should not be a unit that we do, or we do it once a week, taking 2 to 3 minutes daily. So it's going to be brief and frequent to go over facts. And we don't want to cram all the facts at once. We're going to select facts that we're working on. And there are some places that have some progressions for good ways to build on that. But to have a plan and strategically be doing your fact fluency is really important because we can't throw, 300 some odd facts at students and be like, okay, go memorize these or go be fluent with these. So I think on our next slide, we have some strategies that students can use. But again, you're going to want to go back to that explicit instruction Kristin was talking about and explicitly teach your students who are struggling how to use the strategy. And I won't read all these to you, but you can see on there are a bunch of different ones, and you start with one, and as they master them, you can move on to the next one.
Well, and I think also the idea with this is you want to kind of pair the strategy with what the students understand conceptually. Like a student really might understand the whole making 10 facts, and that would be the strategy they really want to use as much as they can because that's what they understand. Or they might be able to, they might be really good with their related facts. So I think the whole idea with this too is that you want to kind of encourage strategies where the students really are there conceptually and they can understand them.
So we had them for addition and subtraction. We've got them for multiplication and division. And then you want to use these not just as worksheets. We want to have a variety of activities that are engaging for your students, Games are great. And again, it doesn't have to be a whole hour of games. We can take 5 minutes by yourself. It doesn't even have to be with a partner, but you can partner them up, have them play some games. Maybe they're doing some flashcards with each other again. And like Kristin said, building on those strategies that we want them working on. They're going to try to use those strategies as they do the games. It's not just random play a game, guess numbers, and we're going to have fun for 5 minutes. We're really trying to build the strategies and the skills that they need to be more fluent so that they can be more successful. So if you have other fluency activities that you use, put them in the chat box, share them with your colleagues here.
A lot of people mention Jill Bowler, Fluency Without Fear. She has a lot of great ideas in terms of fluency activities. And I think probably something else important to note is we should never as far as the whole timed part of it, we really need to be careful with that, because we don't want our kids to be more anxious. We don't want it to provoke anxiety. And like Sue said earlier, being fast is not always, we want them to be strategic and efficient, but we don't want them competing with other people. We don't ever want to have, I remember when I was growing up and we all stood up and we did the multiplication fact race. And if you didn't get it, you sat down. Like, that's just so not good for people's math identities. So you just want to be careful. If you do the graph, if you have kids chart their progress, if that works for them, great, but make it individual. Don't have them comparing themselves to other people.
I agree, Kristin. And another thing, if you have a student who really struggles with that time factor, instead of having it count down, like saying you only have a minute, let them see how long it takes them and then just try to improve their time. That way they have that feeling of completion. I did the 10 you wanted me to do. And this time it took me a minute. And tomorrow I'm going to try to do it in an under minute. So I think that's another way to use time if you want to help them feel a little bit of urgency. But I agree with Kristin. I actually have math anxiety. Believe it or not, I'm a math specialist, but I have math anxiety. So you can overcome it. But to this day, if someone hands me a math problem to do, I get a little sweaty and anxious when I first get it, because I'm like, oh my gosh, what if they're watching me? What if I can't do it? What if I get it wrong? So math anxiety is very real. So I like that you stressed that, Kristin. And people put in their I excel, songs, definitely songs. And then Dreambox is awesome. So is I excel. And Reflex. Reflex is really good because they really do pace the kids. They have them build on facts instead of throwing them all at them. These are great ideas, guys.
All right, awesome. So now we get to problem solving. So Sue, we're going to have to try to get this in 32 minutes, but it's going to be a lot of information. But again, this is kind of just like a nice overview and to give you some exposure to these ideas, and all of it can be found in much greater detail in the resource guide. There's lots of specific examples. There's appendixes that have different examples of what we're going to be talking about. So it might feel a tiny bit overwhelming because we're doing it so fast in 30 minutes, but hopefully it will give you the incentive to find out more and learn more about it. So this is just an example of a typical word problem. That's an example from our mathematics quick check 6.5C. We'll talk more about those in another session. But really, problem solving is really why we're doing math, right? We need to know how to solve problems. And it's not just so we can solve problems on the SOL test, it's so we can solve problems in real life, right? We need to learn how to be mathematics problem solvers. So just thinking about why might problem solving be challenging for students with disabilities or difficulties in mathematics? So let's just take 1 minute and type in the chat box why you think problem solving is difficult for our students. The reading, definitely. Lots of processing, comprehension, multiple steps, vocab. Yes, all of those things. Focusing, the working memory, comprehension, getting lost, too many numbers. Yeah, all those are reasons why our kiddos have difficulty. So really, you all mentioned these areas in the chat. You all know it's reading problems, understanding the vocabulary, identifying what's relevant, what's the information I need to know, and ignoring what I don't need to know. The interpreting charts and graphs can be very difficult for our kids. And then figuring out what operation do I do? And then actually, once I figure out the operation, performing the computation part correctly. So those are kind of the 7 main areas of why the word problem solving can be difficult for our students, or problem solving can be difficult for our students. So we're going to teach you 3 things today. And hopefully you'll go away with something that you can apply to your classroom. And this one, actually, I definitely want you to apply to your classroom. Do not tie keywords to operations. It doesn't work. And I know we've all done it. I am guilty of using the keyword strategy. Oh, remember these words, they mean adding, or these words mean subtracting. It doesn't work. Evidence shows it does not work. And that's for everybody, not just students with disabilities. Do not tie keywords to operations. But you do want to have an attack strategy. So, and Dr. Morano mentioned some of the attack strategies in her session. We want to make sure our students have an attack strategy, and that attack strategy that they use, they want to use it all the time. So we need to make sure they know how to use it. And that's where that whole explicit instruction comes in. We want to make sure we explicitly instruct our students on the strategy so that they can get to the point where they are using it independently every time they attack a problem. And then the last one is teaching word problem schemas. Now, this is the part that's probably going to feel very overwhelming to you, because we're just doing a brief overview of what they are. But hopefully it'll kind of inspire you to learn more about it, and we'll give you a lot of resources that you can go to learn more about it. But it's very evidence-based when we're teaching problem solving to teach our students word problem schemas. And the earlier we can teach our kids these schemas, the easier it will be for them as they progress through math. All right, so real quick, make the point here. If you have any of these posters hanging up in your room, take them down. If you have them in your virtual classroom, take them down. We don't want to tie keywords to operations. 1, because half the time it doesn't work. And 2, does that really support our students' conceptual understanding if they just memorize certain operations go with certain words? That doesn't promote conceptual understanding at all. So if you take anything away from today, don't tie keywords to operations, because again, half the time it doesn't work. Here's an example of where the word share does work for division, and then there's an example of where the word share does not work. So half the time they don't work, but more importantly, it just doesn't help with conceptual understanding. But we do want kids to have an attack strategy. And I'm not going to tell you one right attack strategy to teach your students. There's several attack strategies. And here are just a couple of examples. Dr. Morano mentioned the understand, plan, solve, check strategy. Here's an example, ridges, rice. Most of them start with the first step of reading and understanding the problem. But the main thing is that whatever strategy you decide to teach your students to use, that you explicitly teach them how to use that strategy, and you're doing that instruction like you are working on in Dr. Morano's session, so that they can get to the point where they're using that strategy metacognitive on their own. And every time they attack a problem, they just automatically use the problem solving strategy.
And we worked with a school, an elementary school, where they decided they were going to pick one as a school to use to keep it consistent for kiddos from when they're in kindergarten till they're done in 5th grade. That way they weren't trying to learn a new one, because with those kiddos with disabilities, a lot of times you teach them something new, they don't make the connection that it's just a different way. They think it's something completely new. So I like that idea of maybe having a whole conversation as a school of a strategy we want to.
Okay, and then the last piece that we're going to talk to you, well, actually, here's some more examples of this. Is actually a more detailed example of the UPS strategy, and there is a separate folder in our folder that has all of what we're talking about with word problem strategies and different resources. So this last piece, this is going to be a quick 25-minute overview of schema-based instruction. And I will tell you right now, you're probably going to feel a little bit overwhelmed. It's a lot to learn. It's a lot to learn about in 25 minutes. But hopefully, like I said, it'll kind of inspire you to learn more about it, because it really is evidence-based for our students who struggle with mathematics, for our students who have disabilities in mathematics. And it really is a evidence-based way that they can approach problems. So this is called schema-based instruction. So it's abbreviated SBI, not SDI. And it's where students learn how to use cues and word problems to determine the type of problem, and then they create a visual model. And they learn concepts to choose the appropriate procedures. So it's really a way to categorize problems, and it's focused on reasoning. So rather than teaching keywords, which is not focused on reasoning or conceptual understanding, schema-based instruction focuses on reasoning. And it has 3 components. The students identify the problem, or it's problem identification, which is where they recognize the type of the problem or the structure of the problem, which is, I think of schema as the structure of the problem. And then they represent it into a diagram. And a lot of times our kids really benefit from that visual diagram representation. And then they look at that visual representation to figure out their strategy. What are they going to do to solve that problem? So we have 6 schemas. We have additive schemas and we have multiplicative schemas. So there's 3 schemas in the additive group. We have our total, difference, and change. And then the multiplicative group has equal groups, comparison, and ratios and proportions. Now, you guys are elementary teachers. You probably won't really get to the ratios and proportions. That's not really hit until middle school. But you'll definitely be dealing with the total, difference, and change with your additive. And then when kids start learning multiplication and division, that's when you're going to be working with your multiplicative schemas. All right, so I'm going to just give you a quick overview of the additive ones. So the first one is total. And a total, for those of you who are familiar with the math curriculum framework, total problems are referred to as part, whole, or combined. It means the same thing. But basically what it means is you have parts, and I'm going to show you the gestures now because we're running out of time. But another multimodal way that you can do this when you're teaching your students is the gestures to go along with the schema. So you have parts put together to make a whole. So that would be the gesture that goes with it. Parts put together to make a whole. And here's your diagram that would go with it. So you have your parts put together to make a total. So, and any part of the schema can be missing. The first example, the total's missing. The second example, one of the parts is missing. The third example, one of the parts is missing. So when you're teaching students this total schema, they're then looking at their problem and identifying what parts of the problem go into the graphic organizer. So here's just a quick example. Megan has baked 28 sugar cookies and 24 chocolate chip cookies. How many did she bake in all? So if the student would identify that this is a total problem and would complete the graphic organizer. And when they look at that graphic organizer, they would look at that and say, you know what? I have a part, and I need to put them together to make a total. So I'm going to add those 2 parts. The other, the second additive schema is the difference schema. And in this schema, in our curriculum framework, it's referred to as compare, but it means the same thing. So in a different schema, you have a larger amount. So when you're thinking about the gesture that goes with it, you have a larger amount and you have a smaller amount, and you're looking at, I'm trying to figure out, okay, here we go. We're looking at the difference. We have a larger amount, smaller amount, and we're comparing it for a difference. So what's that difference? And again, you might have different parts of the problem missing. Okay, so in this example, we're missing the difference. So you put your greater number. So this is the graphic organizer that goes with this. You have your greater number, then you have your lesser number, and you're finding the difference. And I apologize, I'm not going through every single example because we don't have time, but you do have this PDF, and the resource guide has this explained out in much more detail with a lot of different resources to go with it.
And there's a book you can buy too that actually has like scripted lesson plans you can follow. We again, that same school that Choose to Attack strategy, they started doing this as an intervention with their kids, and I cannot tell you how important those gestures are. Like we would watch the kids when they got to the independent practice part, and you only do one at a time, one of the schemas at a time. But we would watch them sit there and be like, they'd be like you could totally see them doing it. So don't skip that part.
Okay, somebody said they didn't see my hand movement. So a difference one, you have your greater amount and your lesser amount, and you're comparing the difference. So in this problem, the 107 wooden beads is the greater amount. The 68 beads are the lesser amount. So what's the difference between those two numbers? And the cool thing about schemas, and this is another great, because there's more than one operation to solve this. Some kids might look at this and subtract. They might do 107 minus 68 to get the difference. But some kids might look at this like as an adding up problem. 68 plus what gives me 107. So that's the other really cool thing about it, is because it's in a structure, the students visualize it, and really just depending on what their conceptual understanding is, determines how they're going to solve it. Some kids will see it as a subtraction problems, but others will see it as an adding up problem. And then the last additive schema is your change schema. And that is where you have an amount that increases or decreases. So you have a starting amount, and that amount either increases or that amount decreases. That's what the gesture looks like. That amount increases or decreases. You could also do it like a number line. You have a starting amount, it increases, or I don't know if I'm mirrored or not, but you guys know what I mean. It's either going to increase or decrease. And again, depending on what the problem is asking, it might be asking for the end number, it might be asking for how the change number, or it might be asking for the start number. But once the students can put the numbers into the graphic organizer, then they can look at it and conceptually decide how they want to solve it. So that first slide was change increase, where the amount increase, but you also have change decrease, where you have a starting number and you decrease it. But it's the same graphic organizer. So the change, whether it's an increase or decrease, the students would use the same graphic organizer. So here's just an example of how somebody might use it with the strategy and the graphic organizer. So again, I'm doing this really quickly, and I apologize, this is so fast. But once the students complete the number, so the bus started with 13 passengers and it changed because a number of passengers got on the bus, so it increased, and it ended with 28 passengers. So we're trying to figure out what that change is in number of passengers. And again, some kids might look at it as subtraction. Oh, I can do 28 minus 13 to get 15. Or some kids might add up 13 plus 15 equals 28. Okay, so I showed you the schemas, but in your PDF is linked to this video. Sarah Powell was one of the University of Texas professors that collaborated with us on these documents, and she has a bunch of resources online with schema-based instruction. So this goes directly to the gesture. So if you didn't remember what I did, you can look at them on this video. All right, I'll know, Sue, if you can go as fast as I can. We want to try to get through this. So we spent a lot of time creating a Jamboard activity we want you guys to try.
Yeah,
I don't know if we're
I think
it.
It's something you can use with your students, just the concept of using it, how you can use a Jamboard. So I'm going to fly, but I
You know
think you got
what?
the idea from the additive.
Yeah,
Go
and I
ahead.
wonder if maybe you can skip the
Should we just
ratios and
go to it?
skip the ratios and
Yeah,
proportions, since they don't really have to do that in elementary.
I'm going to skip the strategy piece too, since we've already gone over that. So the first one is equal groups. And for equal groups, the hand gesture is this, because the whole idea is that you've got a number of groups that are multiplied by the same number. So like for equal groups, it would be, I have like a bag of apples and there are 6 apples in the bag. And I have 2 of those bags. So here's a bag of apples with 6 apples. Here's a bag of apples with 6 apples. So each time you have your, whatever the unit, the number, the thing that's being the group, and then the number of things in that group being multiplied. Okay. So you can see here, that's what we're doing. Tanya had her apples. She had a bag, two bags. Each bag had 6 apples. So I can see that I have a group of 6 in a bag and then a group of 6 in a bag, and then I'm going to get my product. And again, different pieces can be missing. Students might attack it as multiplication or division based on what they're comfortable with. But at the end of the day, they're going to have a way to read that problem. Oh, this was all about cherries. When I read this problem, I can see this one, we're talking about cherries. I can see that they've got some cartons. So that's a thing that holds stuff. And each carton has 25 cherries. So I'm going to have 6 of those 25s. Does that make sense? And then again, different pieces might be missing, but I'm going to use that same graphic, plug my numbers in, and then figure out what the answer is. And then we have comparison problems. And for comparison problems, again, just like before, how we were doing the difference this way, this time it's you have a set that's multiplied a number of times. So imagine like hopping on a number line. So if I was on a number line, so Sam picked 6 apples and Elizabeth picked 2 times as many. So 6, 2 times. So that would be 12. And again, I put the links to the videos, and you've got the links on your PDF to go to the videos. If you watch them, Sarah really goes into them. And again, using my strategy, I would just focus on, what am I talking about? Oh, I'm talking about books. And I can see that someone has more than someone. We're going to see how many more or how many less, so that I know I'm talking about comparing things. Anytime I'm comparing what 2 people have, it's a comparison one. So that's where the strategy piece comes in. And then
Okay,
ratios is just, if this is this, if this is to this, as this is to this. So you can watch the video, and you probably won't get into those until middle school.
We want to do this.
So,
we spent a lot of time making it, so we want to at least get you guys in for a little bit to work on this activity.
And again, you're just going to...
Everybody, we apologize. You didn't have a whole lot of time to play in your breakout rooms. If you had more time, you could have started to try to fill in the graphic organizers with the missing, with the numbers that you knew for each problem. But that was just kind of a quick, fun activity for you to kind of just, be exposed to the different schemas. Obviously, this will take a lot more of your time to really learn about them and learn and know enough about them that you can use with your students. But just like with everything else that we're talking about, you're not gonna do what we did with you guys and say, okay, guys, here are 6 schemas. I'm going to teach them to you today, and you're going to use them. Like, that's not what you're going to do, right? So you just one at a time. Teach the total schema first. Teach that one explicitly, model, do all the stuff that we talked about until your students really are comfortable with it. Then you introduce another one. Then you teach the difference one. And then maybe when they're comfortable with the difference, then you could do total and difference together at the same time. So you have to be very intentional and very structured and explicit, and not do what we just did with you guys. We were just kind of giving you guys a big overview, but we don't want you to do that with your students. They would definitely not be happy. But the PowerPoint gives you some instructional tips, and we're almost out of time, so I can't really go too much into detail. But again, I just kind of gave you an overview. You're going to make sure that you explicitly teach it, that you're using simple, direct language, lots of practice opportunities, that whole idea of gradual fading support. And, like I said, you do one till they learn proficiency, then you move on to the next one. And it's really a good idea that when you're teaching it to use simple problems, because you don't want the students to be, I mean, if you have to use a problem that's from a couple grade levels below to teach the schema, that's totally fine. You don't want them to be bogged down in the content. So,
and actually, when you start, according to that book, they have them start with all the numbers there. They literally are focusing on the schema, not
right.
trying to solve a problem, just what are the pieces and what kind of problem is it?
So there's a lot of resources in your folder. And then also these links are actual webinar series that you could really, and modules, if you really want to learn more about it and how to use it in your classroom, I definitely recommend you checking out these modules. But we just kind of wanted to give you an overview and hopefully inspire you enough to learn about it and maybe try it in your classroom. And I think that's all we have time for. This link, I encourage you guys to use to sign up to get our special ed instructional newsletters. And that kind of keeps you abreast of things that are happening across the state. And then just lots of links with different math resources we have on our VDOE website. And we don't have